Hello, everyone. Welcome to the What's New session about running advanced ML in Snowflake. Very excited to talk to you today. My name is Pawan Potukuchi, and I am a director of product management for AI ML here at Snowflake. And alongside me, we have Sandeep Gupta from my team, who leads several areas of the Snowflake ML product. The agenda for today's session will briefly introduce you to Snowflake ML and go over a set of advanced ML use cases you can build with it. We'll start with a few customer stories after that and cover some of the newly released and announced features in a bit more detail. Before we go into Snowflake ML introduction, let me briefly walk you through Snowflake's AI ML stack. Snowflake has a unified AI platform for development and governance to help enterprises unlock new levels of productivity and insights in an easy, efficient, and trusted way. This is regardless of whether the use case is using generative AI or machine learning or both. To efficiently build AI applications, Snowflake enables you to bring AI closer to your data and not the other way, unlike other AI platforms. This prevents data silos and enables faster iterations across your data and AI infrastructure. To enable more than just a few technical experts to use AI, Snowflake offers fully managed services and infrastructure that just works and is easily accessible via code and no-code interfaces. And lastly, to protect your models in a trusted manner, Snowflake extends governance and granular role-based access controls from your data to your machine learning models without any additional complexity. Now let's zoom into Snowflake ML more. Snowflake ML provides a comprehensive set of modular and integrated capabilities for end-to-end ML in Snowflake across 3 different layers. At the bottommost layer, we offer ML infrastructure that is optimized for large-scale distributed training and inference. This includes several cost-effective choices of GPU and CPU instance types, pre-configured Python packages, popular ML frameworks like XGBoost, and deep learning frameworks such as PyTorch. The middle layer offers tooling for business analysts, data scientists, and ML engineers to develop and operate ML models at scale seamlessly. For example, analysts can use ML functions to shorten development time for common scenarios, such as forecasting and anomaly detection using just SQL. Data scientists can use Snowflake ML Python APIs to easily train large deep learning models. And ML engineers can deploy these models and monitor their performance at scale. The top layer offers a set of IDEs, including a no-code studio and a notebook interface to build ML applications in an integrated manner right in your Snowflake environment. These capabilities are available to use in a modular way. For example, you can train an ML model in your favorite ML platform outside of Snowflake and deploy that model in Snowflake using Snowflake ML. This enables you to run predictions and store them right where your input data is stored. Alternatively, you can run both training and inference in an end-to-end manner, all in Snowflake. The choice is yours. So to quickly recap the benefits of Snowflake ML, Snowflake ML enables you to run large-scale training and inference jobs right where your data is. There is no need to move data, create silos, or lose auditability. Secondly, Snowflake ML is easy to use and managed. You do not have to worry about configuring or maintaining ML infrastructure. Just focus on your model performance. Lastly, Snowflake ML extends the familiar governance controls available through Horizon from your data all the way to your ML models, making it easy to discover, manage, share, and govern machine learning models and features. Now let's see what kinds of use cases can be unlocked with these capabilities. You can use Snowflake ML to build advanced machine learning models for a variety of use cases, including recommendation systems that can use history of clicks or purchases to tailor targeted marketing or sales campaigns. Custom embedding models to generate text embeddings at scale for similarity search or RAG-based applications. Computer vision models to detect anomalies or classify images based on custom taxonomies. And lastly, large-scale tree-based models with distributed training for things such as lifetime value predictions. We'll now cover each of these use cases in a little bit more detail. Building recommendation systems involve large-scale data processing and using deep learning frameworks such as PyTorch. With the new distributed training APIs from Snowflake ML, you can easily set up and run distributed training jobs across multiple processes. Now, for each of these use cases that I'm talking about, we have also linked a quick start that will guide you to the process of choosing a sample data set, loading your data, performing feature engineering, training your model, and running predictions. I encourage you to check these out after today's sessions. Using computer vision models to detect issues in quality control processes is becoming increasingly common in manufacturing workflows. Other use cases include classifying images for content moderation or search-related scenarios. Here too, using deep learning frameworks and open source algorithms is typically the way to go. With Snowflake ML, these frameworks are built into the runtime, so all you need to do is spin up a notebook, select a GPU runtime, load your data, and off you go. With advances in LLMs, generating embeddings, which are numerical representations of your text or multimodal data like images, is possible. Several downstream applications like looking for similar product descriptions or images becomes pretty easy after that. However, generating embeddings at scale is a hard problem, as it is compute intensive and greatly benefits from parallelization. We have managed services like Cortex embed functions that make it super easy for you to generate embeddings for such use cases. However, when you have to build or bring in your own custom embedding models for a language this function does not support, or for custom data use cases, you can now bring such models and register them into Snowflake Model Registry, and then serve these models for inference on Snowpark container services. This process is extremely easy and takes only a few lines of code for you to implement. Snowflake also has a native vector data type for you to store these embeddings and things like cosine similarity functions for further processing. You all are likely very familiar with tree-based frameworks like XGBoost to build classification models or customer lifetime value models. If you have a lot of data to feed into these models, you can now use distributed training across GPUs to build them a lot faster. Snowflake ML APIs take care of distributing and orchestrating your training jobs across the available compute automatically. What more, Snowflake's ML data connector APIs makes the process of loading the data from your Snowflake tables into your notebook environment significantly fast too. With that, now let's spend a few minutes to learn about how some of our customers are using Snowflake ML to build sophisticated ML models and applications. Many customers such as Ecolab, Invista, and Scene have built mission-critical ML models using Snowflake. These range from classification models to improve customer matches, market basket analysis models to analyze purchasing patterns and recommending new items, CRM models to predict customer lifetime value and tailor promotions based on that, supply chain forecasting models to predict delivery dates, and lastly, propensity models to determine if a customer would subscribe to a specific product or service you sell. I'm going to dig deeper into a couple of these customer stories to provide some more color. Scene, a Canadian loyalty program provider, built propensity models in Snowflake ML to develop marketing campaigns. They were able to reduce inferencing time by over 60% due to the automated distribution processing available in Snowflake. They were also able to reduce their cost by 36% as their ML pipelines are a lot more efficient without any data movement needed. Another customer, CHE, they're a healthcare staffing company that enables providers to get both permanent and temporary jobs. They build ML models for a variety of optimizations in their business operations. They faced a number of challenges, including frequent outages in their ML applications and slow coarse-grained results. Snowflake ML enabled them with better data preparation, model building, and serving experience. As you can see from this chart of architecture, for data preparation, they're now able to use many sources of data, including structured, unstructured, and third-party sources from Snowflake's marketplace. Model building runs entirely on Snowflake resources, improving performance. Snowflake Model Registry made collaboration easy, records important information, and with Python and SQL interfaces, it makes it really easy for them to use. They found that this approach keeps datasets secure on the Snowflake platform, enhancing data integrity and security. Efficient machine learning and a single source of truth via the model registry streamlined their processes. And lastly, multifaceted model deployment using Python, Snowflake, and Snowpark Container Services solved several of their pain points, leading to better outcomes. With that, I'm going to turn over to Sandeep to walk through some of the latest and greatest capabilities from Snowflake ML. On to you, Sandeep.
Thank you, Pawan. Let's now take a closer look at everything that Snowflake ML has to offer. So your ML development in Snowflake starts with Snowflake Notebooks, which is a powerful and easy to use IDE for all your interactive development needs. Snowflake Notebooks are built into Snowsight, and they support cell-by-cell execution for both Python and SQL code. By using Snowflake Notebooks, you can increase your productivity as it simplifies connecting to your data in Snowflake, and also it makes it easy to use popular open source libraries for machine learning. You can create a new notebook, or you can start from any existing IPython notebook that you might already have. It also supports connecting to a remote Git repo for version control and collaboration. And also these notebooks can be set to run on a schedule to help you orchestrate your pipelines. In addition to using notebooks that run on the warehouse, you now have the option of using notebooks that run on a fully managed ML container environment built specifically for large-scale ML workloads. This new runtime gives you access to distributed compute pools with CPUs and GPUs. It is optimized for fast data ingestion from Snowflake, and it gives you the flexibility to run any ML workload. To get started with notebooks on container runtime, when you create a new notebook, just choose Run on Container option as shown here, and select the appropriate CPU or GPU-based compute pool that's listed in your options. So Container Runtime for ML is now available in public preview on AWS. It consists of pre-made container images of CPU and GPU ML packages and frameworks, which means that it eliminates most of your package management and dependency-related headaches that you may encounter. You can quickly get started with any framework of your choice, plus you can pip install any additional or custom packages that you may need. You can also bring in models from any external sources. Next, it has an optimized data ingestion layer and a set of powerful APIs for training that extend well-known ML packages to be able to train models efficiently in Snowflake. And this is all backed by a distributed compute cluster, which is powered by Ray, and that gives you access to CPU and GPU resources for your workload, so you can get high performance and optimal use of infrastructure without having to deal with any of the complicated setup or configuration that you typically have to do for distributed training. So now once you've trained a model, you are ready to productionize it and operationalize it. And for this, Snowflake offers a full set of ML Ops capabilities. The entry point to ML Ops in Snowflake is the Snowflake Model Registry. This is our native solution for managing, deploying, and using AI and ML models in Snowflake. To use the model registry, you start by first logging a model. You can log any model that you have trained in Snowflake, but in addition, you can also bring in models that you have trained externally on any third-party platform or from open source repositories in any of the supported model formats that are shown here. If your model is not one of the supported types, then you can use our custom model API to still be able to log it. Once you log the model, it creates a secure and governed first-class model object in the backend. And this model object is used to keep track of your model versions and all of the metadata and metrics that are associated with the model. Model registry helps you unify all aspects of model governance and management. So before model registry, many of our customers were writing ad hoc UDFs by hand to create model inference functions. Now, model registry provides lots of advantages over this. First of all, it is a unified catalog of your models in one place, which includes your custom models as well as any Cortex fine-tuned models, LLM models, for example. It supports rich metadata, metrics, tags, and versioning. Also, models in the model registry are inference ready, which means that they're automatically deployed and available for inference, which you can call from SQL or Python in the warehouse. You do not have to do anything additional to do this. And like everything else in Snowflake, you get all of the governance benefits through the model object, such as fine-grained role-based access control, ability to manage the life cycle of models as they move from dev to production. And there is also built-in end-to-end lineage from which you can see the sources, the source data and features that the model is using. And lastly, model registry simplifies collaboration, and it gives you several ways of securely sharing models both within and across your accounts. Model registry is now available from the Snowsight UI as well. So from the models menu in the AI/ML section, you can find all of your models and model versions, which makes it easy to work with these models. You can look at or edit all of the model metadata and metrics. You can see the model functions. You can see their signatures. And also you can visualize the lineage of the model as you see in this image here. And lastly, you can list all of the model artifacts and the files and download them as needed. So let's take a closer look at inference from model registry, because that is one of the main purposes of why you are deploying models in the first place. So when you log a model in the model registry, Snowflake automatically deploys the underlying model function UDFs in the warehouse. And then you can call these functions from SQL using model predict or from Python using model.run. And these functions will run distributed inference using all of your warehouse nodes. Now, in addition to this, we now also support serving models for inference using Snowpark container services. So this provides you all the benefits that you talked about earlier with container runtime in the development section. Namely, that you have access to GPUs for GPU-powered inference, and you can bring in any pip packages that your model needs. So to serve a model on SPCS, use the new Create Service API, and behind the scenes, this automatically creates a custom model inference container image for your model, and it deploys and starts the service. So you as a user do not have to deal with managing these inference servers or managing container images. Once the service is deployed, you can now run inference using this service from SQL or Python, just like you would from the warehouse. And in addition, you can also call the model from a REST API endpoint, which means that your application can connect to the model from outside. So model serving is now available in public preview on AWS, and support for Azure deployments is coming soon. So another key component of ML Ops is explainability and observability. ML models can often seem like black boxes, especially as models get complicated and deeper. So often it is necessary to understand and explain the behavior of a model. This may be for compliance or regulatory reasons, or it may simply be because you want to understand model failures or unexpected results so that you can improve your model. So Shapley values are a common technique to help do this by calculating and analyzing the impact that each feature has on the final outcome of the model. These Shapley values, however, can be cumbersome to compute. They usually rely on third-party libraries, and they need access to your data, plus they can be computationally expensive. With Snowflake's model explainability, you get access to these values conveniently and efficiently without leaving Snowflake's secure environment. To use model explainability, you simply log a model in the model registry, and for supported model types, you can just call the new explain function to compute these Shapley values. You can check out our documentation and see some examples of this. Now, monitoring the full health and performance of your models, however, goes beyond just explainability and feature contributions. Because decisions made by your models can have a massive impact on your business, therefore, monitoring models in production for performance, for drift, for quality of incoming data, this is all necessary to ensure that the decisions made by your models are trustworthy. So Snowflake's ML observability completes the story of the end-to-end operationalization of a model. Here, once your model is deployed in production, you can track its performance using a variety of metrics that are automatically computed on model predictions. And if your defined thresholds are exceeded, you can ensure that the right person or process gets alerted. And so you can take appropriate action, such as downgrading the model or training the next iteration of the model. All of these observability tools can be accessed from the model registry UI in the monitoring tab. So in addition to managing your ML models in Snowflake, you can also manage your ML features in Snowflake using the new Snowflake Feature Store. Feature Store is our native product that helps data scientists and ML engineers author and define features, use Snowflake to maintain and update those features as new source data comes in, and then serve those features for use in training or inference pipelines. There are 4 main benefits of using the feature store as part of your ML pipeline. First, Snowflake keeps your features fresh and updated automatically, so you do not have to worry about creating tasks and streams and orchestrating your feature pipelines. Second, there are easy to use APIs to define most of the common types of features that you need, and you can do this in SQL or in Python. Third, Feature Store handles all of the point-in-time correct joining. So what this means is that when you retrieve features, they are accurate and consistent based on your desired timestamp. And lastly, Feature Store makes it easy to find and reuse existing features, therefore driving increased productivity. So Feature Store is now in GA, and there are quite a few new things that are supported now. These include a new UI for browsing your features, integration with universal search, so you can easily search and discover existing features using rich metadata. Features can be shared or replicated within or across accounts. We have also expanded the support for training dataset generation so that now features can be consumed more easily both inside and outside Snowflake. And lastly, Feature Store has built-in ML Lineage. So we have mentioned Lineage a couple of times in this talk. Let's take a closer look at this. ML Lineage is part of the Snowflake data lineage capabilities in Horizon, which now extends to all of the ML artifacts as well. With ML Lineage, you can trace ML object dependencies and get end-to-end lineage across your data sources, features, datasets, and models. Using ML Lineage, you can answer questions about which features or source data did a specific version of a model use. Or in the other direction, let's say you have some sensitive data and you quickly want to know what are all the models that were trained on this sensitive data. ML Lineage is integrated in Snowsight UI, and you can find the Lineage tab in the respective object pages. And this is available as public preview to all users. So in summary, we have covered at a high level the full spectrum of the end-to-end ML offerings in Snowflake ML. With that, thank you so much for watching and enjoy building. Thank you.